This is Mrs. O'Neill for AP Chemistry, Chapter 6, Section 6, Representations of Orbitals. So the objective for this section is to understand these three-dimensional shapes and how they're represented by graphs of electron density. So in other words, where that electron is most of the time, the most probable place, the highest density in that atom. So the shapes give us this visual. Oh, again, remember to pause the video, fill in the blanks, and then play to hear my words. So these orbital shapes just give us an understanding of how the density of those electrons are around the nucleus. So again, if this is an atom, we have the nucleus in the very, very center, and these blue dots represent the electron and where that electron is most of the time. So if we think about hydrogen and that one electron that it contains, most likely it's going to be in the area of that first energy level. But now remember, it can be excited. So it's in its ground state, it's excited, it jumps up to energy level 2, 3, or 4, and then it jumps back down, right? So it has a ground state, it has an excited state, it kind of moves all over the place. So we want to remember that this is called the electron density because that's where that electron is going to be most of the time. But that electron is moving in 3D, okay, and we want to remember that, 3D like a basketball, right? So that electron can be anywhere, but we are just going to say for hydrogen that one electron most of the time will live in its ground state in energy level 1, which again is where this most of the blue dots are. So these shapes, we just want to remember that the S shape is like a ball. Again, here's our nucleus, and we want to remember that it is three-dimensional, but the electron density, or most of the time that one electron is going to be in that first energy level, but again, that electron can be at any given space in that atom. We also want to remember that as we increase energy levels, right, so we're going to have an S shape in the first energy level, in the second energy level, and in the third. And of course, as we increase energy levels, the size of that ball or the size of the shapes increase. The P is represented by a dumbbell, and again, look at where the electron density is. Now it's not really around the nucleus, now it's on the axis. So if we look at the Z, the X, and the Y axis, that electron density now is not going to be as close to the nucleus as the S. Now it's going to be a little bit more on the outside. And when we talk about hybridization, this is really going to be important, especially the S and the P when we talk about hybridization. There's hybridization that also occurs in the D and the F shapes, but not as, those are a little bit more complicated, so we won't get into that. So here's all three of them together, the P shape in the X, Y, and Z axis. So the D is what they either call a four-leaf clover or a donut, because these are your possibilities. Again, think 3D. So if you have all of these together, and then of course you have this donut shape, okay? The F is a flower. Again, now you have 7 different possibilities, and again 3D models, and they can go all over the place. So as long as you know your S and your P's, you're good. They don't really ask too much about the D's. Okay, see you in class.